Hello, my name is Lin Ma, together with my partner Lam Chun, and under the guidance of our professor David White at Denison University, we conducted a research called a statistical analysis of drug seizures and overdose deaths in Ohio from 2014 to 2018. To start, we believe this is a very important topic to cover because Ohio has ranked the second place in the nation for drug overdose deaths in 2017, and fentanyl is believed to be the leading cause. As fentanyl is extremely potent and impossible to dose correctly, illegal drug branches involving fentanyl could quickly lead to massive overdose death cases. So in this research, we examined the association between drug seizure and drug overdose deaths in Ohio from 2014 to 2018. Here are two data sets we use mainly, and those are two monthly data sets from 2014 to 2018 for Ohio specifically. And the first one is about drug seizures from Ohio Bureau of Criminal Investigations, Crime Lab. And that's for each drug seizure, we have drug count and weight, and also chemical composition, as well as type of different law enforcement. The second data set we have there is from CDC, and that's for unintentional drug overdose deaths. And for this data set, we have deaths count per month. When it comes to methodology, we mainly use two models and one test at the end. For the first model we use is a linear regression model. We use it mainly between fentanyl seizures count and overdose deaths over time. This is to explore the degree to which seizure lags behind death and qualify if the strength of this relationship. We also want to know, does the weight of the drug seizure matters? We believe linear regression model can help us to understand the weight distribution for different seizures, and also to predict death counts from seizure counts and weight. The second model we use here is a Riemann model, and we use it to factor the path into the linear regression model. For the third one, we use a test called the Kolmogorov-Smirnov test, and the histogram here. We use this test to consider the relationship between type of different law enforcement and weight distribution for different seizures. I will hand it over to Lem for the future part.
Moving on to our first layer visualization. In this slide chart, the blue line is the number of death counts per month, and the red line is the number of all fentanyl seizures per month. We also have this green line here, which is the number of carfentanil seizures by month, and carfentanil is a very potent kind of fentanyl drug, but for now we only focus on the blue line and the red line. So we see that the red line follows the blue line very closely, so it is not surprising to us if the result came out that fentanyl explained for a lot of overdose death. And also we were interested to see if there was any lag between the two lines, meaning that if the police seize the fentanyl in the market, like on the market, after they have caused a lot of deaths. And then moving on to the real results after our analysis, fentanyl involved drug seizure count and weight explained for 78% of variation in deaths in the same month, which was not surprising to us. But what was surprising to us was that there was no significant lag between fentanyl seizures and deaths, meaning that the police would seize the fentanyl at the same time that the drug batches caused a lot of death on overall in Ohio. We also concluded that smaller weight seizures have a stronger effect on death than large weight seizures, meaning that if the dealer mixed in fentanyl in smaller weight batches, that would cause more death. The seizure count and weight are significant even in time series model. And finally, there were statistically significant differences between weight distribution of seizures by national, specialized, and local law enforcement. So to elaborate on the last point, moving on to figure 2, we see that the regular forces seize a lot of smaller weight drug batches, while the specialized force seize more medium weight drug batches. For the national forces, they seize an equal amount of small, medium, and large weight batches. And because we have concluded that the smaller weight batches are the most dangerous, we also concluded that the regular force are the most efficient in preventing overdose deaths, especially considering they are the most low funded. So, in conclusion, the local police are the best at seizing low-weight drugs, which is the most dangerous drug. When we consider the iron law of prohibition, we see that when drug seizures increase, more potent drugs enter the market. So the policymaker should really consider this part when they make policy about this. Moving on to the big picture, we also think that data analytics could bring new insights into the drug fight, and so on. The crime lab should make more data available for our analysts, so we could help fighting the drug fight. So that's all for our presentation. Thank you for listening.